Hi, I'm Pagata12, and today we play with particles and sensors, but a little bit different way for the sensing for collisions with any shape. When I say any shape, we previously done circle packing, and that goes for circles, and in this case, we have quite complex shapes, so doesn't matter how many holes they have, or if they are convex or concave. And I would like to show you what's the difference. Okay, so let's have a little recap. So for the circles, okay, I'll have a big one. Okay, the sensors were points outside the perimeter. Okay, and yeah, depends how many you got. So the other one had the same, and so they can sense if this is free of collision or not. And yeah, but the problem with complex shape is let's have a number. Okay, so let's have a number 2. So let me okay, something like that. Oh, quite fat, but the idea is for this shape, I would like to have the sensors a little bit outside of the perimeter. And let's suppose we have the points. It's quite easy to have those points, okay, because we use a text swap, so then we can have some points, right? And while for the convex shape, like here at the top, okay, you can spread the points outside a little bit with no problem. Here, when we have a concave, or if this angle it's small, if we want to have the sensors a little bit outside, okay, so we lift them up along the normal. Okay, we can compute the normal. We have a bunch of points. What happened is here in this little corner, the points get super messy. Okay, so yeah, it's really hard to tell what's the contour. And as I said, while on this surface it's oriented outside, you have no problem. Okay, here, or yeah, it can be also here, depends on the distance. And also you can have some tricks and use blur and stuff like that, and then your line would be nothing like precision, but something like this. So yeah, and maybe there the line will go, yeah. And I really want to have this precision. Okay, now instead of let's have a case with two different shapes. Okay, so I'll have let me use white. So I have a shape here, doesn't matter, and another one, it's here, and this one, it's a little bit more complex shape. Okay, and there are shapes in 3D, so we can have points right along the lines. And in the method we we use today, we don't offset this nowhere. So the sensors will be actually the points on the outside perimeter. Okay, so let me use a different color for this one. Okay, like this. So let's see if we can sense something in a precise manner when the sensor is on the line. And for this, let me draw again a bit of a line. Let's see. So we have this line here, right? And let me draw the sensors a little bit bigger. So we have the point exactly on the line, and obviously the sensor it's there too. My question is, what you will sense with this? So when the shape is very, very small, and as we work with pixels, okay, the line, what if the line is like this? Okay, actually, because there are pixels, right? And you might have a case where your sensor depend on how big the shape become, because we start with the shapes very small, and then the shapes grow, and but in the moment it senses another shape, it stops. Okay, now the problem we have, it's that our sensor, they can self-sense. Okay, so I have a shape, and sometimes my sensor, because it's here exactly on the line, can tell me either this color, yes, so inside color, which would be the correct manner. Okay, so I have that color, or the outside, which is 0, it's black. Okay, so we need to deal with this. And now, yeah, I hope it was not too boring, this. So let's close this, and yeah, I'll walk you through. So I use a text, but it can be also, I don't know, a number, or any letter, or if you have a custom shape, a heart, or a bottle, you can track the banana, whatever. So, and yeah, for the sake of the numbers, and I use the ramp values from LFO with ramp, and here, with a little script, are forced to have only 2 decimals, okay? Because otherwise you will have 10 decimals, and those shapes will become like lines, okay? And yeah, we have this sensors folder, okay? Now let's go inside, and here it's a little bit of a bridge, because I go inside with a shape, and I want to render out this shape, and here I duplicate the information in this text, because I want to have it open polygons, okay, like a line outside, because this would be, and obviously they rotate the same, and the line outside would be much easier for me to have points on a line with resample SOP, okay? Now, those points are my sensors, so I want to save them. So we got them here, okay? And how many of them they are? It really depends, because some numbers, okay, have a different length than some others, and yeah, it doesn't matter too much. So right from here, I would like to build the sensors according with the scale of each instance. Okay, so inside here I select the output from the scale folder, okay, which again, it's not complicated, we've done it several times. And then I repack to have to get ready for the same aspect and the resolution to compute them. Okay, so I multiply something that it's here. Okay, so the position for each point from the center for any shape that's going in here, okay, then it gets multiplied with the scale, because we have seekers which looks for the empty spaces, okay, and then when they put a number there or shape, they start growing, and that rampy scale, we got it in a scale component, okay. But yeah, and once we decide the scale, remember we are in the center here, okay. So we multiply also the result here, it's also in the center, okay. So yeah, it's small because right now the scales are very small. There's no empty space here. So if I reset now, yeah, and once we got the size, we add above above our points the seekers, the particles. The particles doesn't move. Those points actually doesn't move. They are very static. You can check this here. Okay, and yeah, I will walk you through the seekers folder. Okay, so we add the set of vectors position for each instance for the sensor over the center points. Okay, so this is all the sensors. Okay, if I stop and try to zoom, you see those are little dots. Okay, so yeah, my camera was stopped, but so we have the sensor here. Let's see the seekers. Okay, now the seekers, it's a noise, a GPU one, that can give us new points each frame. Okay, and yeah, this is good because it's like we have a pocket, and our particles, all of them have a task to do. The task is growing the shape till it touch something. Okay, now during that task, okay, the particle should have the same position, and this GPU noise that can provide a set of points differently from frame to frame, it's like a pocket. It's a pocket when let's imagine I'm a particle, I will start a task to do. So I'll get from the pocket my position, okay, and that pixel should keep that position. Okay, so imagine this pixel, which right now change its value each frame, suddenly stop the color in the pixel here and wait for the task to finish, and then it's changed. Okay, so this goes in a super how can I say, super close relation manner with the scale, because for the scale, let me I will jump in the scale. Let's go here in the scale. Okay, now what we have here is very, very simple. It's the mate technique. Okay, so I start with 0, and I try to count a little value, a step value, and that would be the next radius, or the radius, the scale for each particle. And obviously I want them different, so my increment, it's a noise with offset 1, so most of the center is 1, and it might vary with 2/3 minus or 2/3 plus, and yeah. And then I add this above the mate, which mate, anytime this feedback, this texture goes white, this mate change the values, okay, between those two inputs. And imagine we start with 0, okay, for all the scales, and some of them increments faster, some of them slower, and so they reach to 1, let's say, in a different times, okay. And if you test when they reach 1, for example, you can plug in that texture here, and every time they reach 1, they go to 0, and they increment again, and so on, okay. But in our case, we don't want to reach 1. 1 would be big as the screen, or we lose control, okay. So we want to the radius, the scale, to grow till they touch, okay. So this is why here in this texture, it's a feedback where I take the results of the compute folder. Okay, so in the compute, this is what we do there. In the compute, we compute and see where we have the touch, which one of the particle actually has that touch, and we kill that particle, and the new one gets born in a different place, okay, but it is kept in our texture in that pixel. So yeah, this is the scale. Now we go back here. So now, yeah, the seekers now, they move very fast, okay. This happened because right now there's no space. They find a little black space. They put a shape there, and first step of growing, or the second one, they hit something, and that's why the duration here is so fast. But if we reset now, you'll see the pixel change colors during the tasks of all the particles, okay. So let's see what we have here. Again, we've done this a couple of times already. So I have my input, which before we multiply it with the ratio, okay. So we set the correct ratio, and now we have a feedback which takes over each time that trigger here in the scale, the feedback too, okay. I don't have a better name, okay. It can be trigger, but this one has the white color in a pixel. Then yeah, the same texture decide what value of the pixel will put over that feedback. So doesn't yeah, it stays there till the task is gone. So this is load. I said it's loading the proper duration and position, and yeah, this is one of the most important piece in such a algorithm. Okay, now I have a render. Okay, it's a bit messy now, but I'll try explaining what's going on here. So this part here, I try to see where I have sensor. This is for debugging purpose. Okay, so sometimes you need to see if your sensors are on a correct position above the line for the contour. Okay, so this takes sensors out, all of them, and I see them with point sprites, and yeah. And here we render. You see, we render on the screen each particle growing, okay? And yeah, we use a feedback, because I would like to, when a shape gets bigger, okay, my feedback has to be so clean and not record the growing of the shape. If the shape is convex or some strange contour, during the scale, during the growth, it might ruin the result. Okay, so the feedback has to record the last size of each shape in the moment of touching. Okay, so this is why this takes only that. So what I did, I actually took the seekers out where I have the points, okay, and also the scales out, but I multiply them with the compute out, with what I get from compute out. Okay, what I get from this, which would be the brain, let's say, for this. So now let's go inside there. Oh, let me show you. So yeah, we have this feedback with one, and then we have a noise. And yeah, just for a little variation in colors, because you see, we can have this noise, but I like more subtle chromatic, and then I can have another noise here and slightly small difference, which is something I do like. And then I thought, what if the color would be according with the size of the numbers? Okay, so then okay, we need to use another geometry and render the same like here, but instead of the color being the center in the UV, the center position, here we have the scale value. And if we use this instead, I limit this in between 0, 1. It's much better. It gives you much rich colors. So let me connect this here. Okay. Now you can see we can play with those noise. Let's have only one. And now you see the scale. The color, it's according with the scale. This is super nice. Okay, so we can reset again. Yeah, and yeah, this is only for debugging. You know, when I analyze to see if here my I know what value. With this you can decide the percentage of cover. So what's the percent of cover with white here? Okay, you can do it with average, and yeah, it's 0.2 almost. So yeah, a lot of black spaces. But what else? Let's see. I would like to show you what it's not super precise here, and let's correct this. We either wait for this to fill, or let's do it a different way. So let me show here the parameters. Okay, so we have a resolution X, we have a ratio, a map X for the texture where we keep the seekers and we have the speed. Okay, so right now the map X it's 6 and the map Y it's 4. Let's go with 16 with 9 and reset again. We have way more seekers, so way more numbers. They touch much faster because of the density. And yeah, what if we go here with 64? So yeah, it's really messy. Okay, now here you will see much easier at a certain point. Some numbers, or all of them maybe, after a while gets dirty. So what I mean by this, let's go back with the old setting and try to explain what's happened. Okay, now where this compute, how this method came out. Okay, now yeah, let me go back just a little bit here. Okay, what's happened with this situation where sensors are on the line? Sometimes they can sense 0, or they can sense the color underneath them, which again itself. So that means here when we want to read our sensors, okay, so let's see. I have a feedback which initiate with 0, okay, and here I'll drag the render null out. It's something that I have here in the render, okay, and yeah, I have a null. This I have it a little bit bigger to know that I'm bringing it into other place, like here. And the sensors, okay, now we correct for the ratio, because every time you remap, you need to remap with something in between 0 and 1. So we stretch them on Y, okay, and we have this texture. And I will pause this. My camera will freeze. So each line here is the result for the sensors. Okay. Now, what's happened because of because of that inconsistent reading of the sensor, because it's situated exactly on the contour and sometimes gets 0, sometimes gets the color underneath. Those lines usually, when I let me play again, I reset now, and okay, we don't have touches yet. Oh, you have maybe a couple small, but I don't think we have. So what's happened? Sometimes they read it, the color they have, okay, and sometimes it's black because of the differences of the pixels on a contour. But what we know, the moment two shapes collide, or they try to collide, in this line we'll have the colors either black because of the misprecision of reading, because of the position, as I said, the color itself, and if it goes above something, we'll have another color here. So what I said, okay, let's compare the values, and while my position for the seeker doesn't change, I can always compare this texture with what I got here. And yeah, it doesn't matter how messy the error with 0 or the color gets, because I take off with, this is the texture, very easy, matte square adjust and limit to see where we have values or where we have 0. And then I reorder everything. And to make a cleaner texture, I help them a little bit and I over this above my point where I have my points. So yeah, with this one, let me see if it's here. No, here. So seekers out, but you notice the seekers, we have the seekers in this manner. Okay, so here to add them underneath each wrong sensor, okay, we put them with this repack in this manner. So we actually take this out here, okay, we fit them together, we put them one above each other, and here I check when I get a difference in color, that means somewhere here in this line or whatever, I have some other values. So that means that is the moment of touching. Okay, so I go with subtract. The differences are very, very small, and they happen for just a frame, a fraction of time. You see here where there are, and doesn't matter how many sensors detect a heat. I know I have a heat, so I go with maximum pixel here. Every time on a line I have 1, that means it's something different there. That's my trigger. The next step is just aligning repack in the texture ratio we need. This limit, I believe, is just for because I had some doubts. I have doubt that it does something, but sometimes it's good to force your 0, 1 texture to actually be 0, 1. So yeah, and what else I want to show you? It's if I zoom in a little bit, okay, sometimes this gets very sandy after a while. Now because I record and yeah, my FPS is low, but it's because of the recordings, and this is the reason we go slow with this texture. But after a while, it gets really sandy. And what's happened and how we correct this? It's something that I actually find out a couple of hours ago. And yeah, what I understand is depend on the scale. Because we have the sensors, okay, and we control them with the same scale for the instances, and sometimes depends on the scale. Sometimes all the sensors can be wrong and read 0. So let's imagine we have whatever shape is so small, and yeah, it depends of the interpolation or not, or how remap it's doing its job. Sometimes all of them are black, and that means sorry about that. That means we'll have a situation where something gets born because there's nothing there, right? My sensors are black, all of them. So it's get born. In the next frame, because of the steppy scale, one of the sensors detects a color, because it was actually born above a color. This is when I say it gets sandy. Some little dots above, you can see here, you see? Some little dots above the colors. And that is the reason because we have this. And I remember I noticed this sandy agglomeration with some other occasion, but yeah, they have a fix. So let's solve that situation when because of the little scale, the sensors, they read outside all of them. Okay, so we go here in compute, and here, what if we'll make room in the left for one single pixel? Here would be empty, but the moment we hover, we have the center instance position, so that means in that first pixel we don't have 0. Okay, so yeah, let's do that. Group like this. So we go with pixels. Here we need -1, so the texture will be a little bit bigger. So you see here, but the size. Let me pause. Okay, 282 and 283. Okay. Okay, and we need this again here. Okay, and here on the other side, I would like to cut it off. It's just for passing very secure this comparison. Okay, so let's have another group here, which will try to solve that by cutting down that extra pixel. Okay, so now let's go here and connect this. And yeah, the problem with sandy look is just gone. Okay, we reset again, and you will never see a pixel above a color again. So yeah, this was the fix, and yeah, I believe this is it. And also here, let's explain this. It's just me testing how long it takes the sensing, the duration of the sensing. Okay, so because the most optimum texture like this one that goes into that mate, the last input, it has to give you one value very clean once, you know. And yeah, and here is just for testing. And yeah, we have let's see, sometimes we have 2 times, but that can be also the steps takes to check a new position. And yeah, it's clean. We have this kind of texture. We trail each pixel, and we see much better how clean the texture can be. Okay, so yeah, this is this side. So this was my tutorial. I really hope you like this. We'll go further with this. I really want to see if for a certain amount of particles we can make this moving and trick the physics and bouncing and stuff like that. I believe it's possible, and yeah, we'll see in the future. And thank you so much for your support. It's been 3 years with Patreon, and I want to thank you for the bottom of my heart. And yeah, see you in the next one. I'll have a next one very soon. And that one would be quite interesting, with a crazy method for working with textures. So see you then. Thank you. Bye.